So I found this question yesterday. Predator prey, bears and fish. So it's quite a popular question on the internet. I did a search and found lots of hits for it. Lots of people asking for help with it and whatever. But anyway, let's go through it and see what it says. So write a Java program, or whatever you like, to simulate an ecosystem containing two types of creatures. So there's bears and fish. So predator prey, classic predator prey sort of stuff. Or think of the game of life, Conway's Game of Life, that sort of thing we're thinking about here. The ecosystem consists of a river. We'll assume it's all river for now. Later on we could do things where, or later on you could do things where part of it's river and part of it's land, so the bears can go everywhere but the fish can only go through the river. So that's something you could maybe add later on, but we'll just keep it all river for now. Each cell of the array should contain an animal object, either a bear, a fish, or nothing, a null. In each step, based on the random process, each animal either attempts to move into an adjacent cell or stay where it is. Okay, so animals move around randomly. If two animals of the same type are about to collide in the same cell, then they stay where they are, but they create a new instance of that type of animal, which is placed in the random empty cell. Okay. If a bear and a fish collide, then the fish dies, it disappears, and I guess the bear moves into that cell. Okay, so we got a river. Everything's river. We're going to assume everything's river for now, so the fish and the bears can move everywhere. Things just move around randomly inside the array, within the bounds of the array. Okay, so if two bears collide, they produce a bear in the empty cell they were moving into, and both bears stay where they are, so there's now a third bear, a baby bear. And if two fish collide, then they produce a new fish in the empty cell. Okay, so there's a new baby fish. So we're going to use object creation. We're going to make this an object-oriented exercise. We're going to use the new operator to create objects, and we're going to model the creation of new objects and provide visualization of the array after each loop. Now that's the thing that might scare a lot of people. Visualization of the array after each loop. That's not saying they want fancy graphs or a fancy graphical display or anything like that. We just display the array data to the screen. Okay, to the console screen if you want. Okay, or to a text area or whatever. Okay, so let's start with modeling it. So I've got an empty file here. Predator, prey, bears and fish. Okay, so I've got an empty class here, a Java class, and I'm just going to... So we need to create objects. It's an object-oriented exercise, and it says to create objects of type animal, and if there's no animals in a location, it should be null. Okay, so we need objects, so I might make a class called animal. And also what we need is an array to hold all of the animals, whether they're bears, fish, or we add other stuff later. So we need a single array to hold everything. So whether it's landscape or animals or fish or bears or whatever. So I'll create an animal class. Assume we're just having animals. If we wanted to have other things as well, we could make that organism or object or entity or something. I'll call mine animal for now. And I'll make a class called fish, which extends animal. Extend animal. Okay, and the reason I've made it, reason I'm using inheritance here is that I can create an array of animals, and in that array I can store animals, fishes, bears, anything I like. Okay, anything that extends the animal class. So that's the beauty of making it all animal. The array can hold anything that's animal or any of the subclasses of animal. So that's why it's the beauty of doing that. So create another one called bear, and I'm just creating them as classes here, not public classes, because you can only have one public class per file in Java. So I've got one public class here, which is my predator prey, and I've just got all these other classes here for now in one file, just to make it easy while I'm developing, so I can juggle things around. Okay, so we don't need any data in those at the moment. We're not storing genders and ages and whatever we need for each animal, so I'll just leave them as empty classes. They're just placeholders, really. Okay, an empty class is fine. You don't have to have data and methods in there. That's fine. So we want an array, and it's an array of animal. And an array's got locations. We'll have width and depth. Won't worry about height, and we're not going to have caves and mountains and things at this stage, and tunnels. So we just assume it's a flat river plain. Okay, so we'll have a 2D array width and a depth, or width and a height, width and a length, and we'll call it ecosystem array, eco array, okay, ecosystem array, landscape array, whatever you want to call it, equals new animal. So we're creating a 2D array here, and we want to put in a width and a height. And what I might do is use some constants there, so we're not repeating those values many places. So it's going to be a static final int width is equal to the width. I'll just have a number of characters across the screen, so I'll make it 60 width, and height will be number of lines on the screen roughly. I'll make it 20. Okay, so it comfortably fits in the console screen. I'll start off by displaying everything to the console screen, then we'll look at improving that later. So animal array's got a width and a height. So there's our array of landscape cells. Each cell can hold one animal or null. Okay, so we need a constructor. Public. So it's just a default constructor. I might move my array creation to inside the constructor. So it's created when the object's created, which it is anyway if you leave it up there, but I'll just make it so everything's constructed in the constructor. So there's that. By default, Java initializes all the cells of the array to null, so that's okay. What we might do is place some fish in there, so we've got something to start with. Okay, so we might have static final int starting fish, and I might have 15 fish to start with. I don't know, whatever you think's fair. And what we want to do is place those 15 fish in random locations around the grid. Okay, around this grid here, our width and height, our 60 by 20 grid. We want to just place those fish at random, and so we want to choose random numbers. We want to see if the cell's already blank in the array or null, and if it is null, we'll put a new fish in there. We'll put a fish in there. Okay, so int fish count is equal to 0, while fish count is less than the starting fish. Then we could choose a random number. So what we'll do is we'll get a random coordinate. So that's an x and a y, and see if that location is vacant or null. Okay, null. Okay, and if it is null, then we'll put a fish there. Okay, and increment our number of fish that we've placed. Okay, so let's get a random x. Int x is equal to. Now what we want to do here is use some random numbers. So I'm going to do an import for secure random. So I can use the basic random number class in Java, or I can use the secure random, which gives us much better random numbers. So I might use that, and I'll do an import. Whoops. Java.security.secure random, and so let's now use that. And we're going to generate a random object. So secure random. I might do that at class level because I'll be doing quite a bit of random number stuff. Random equals new secure random. So that initializes our random number generator, and then we use this object here of type secure random to generate random numbers. Okay, so down here we'll go equals random.nextInt, and we'll give it the range we want. So it's between 0 and our width. So x is our width coordinate, or our horizontal coordinate. And just to give you some notes here, that gives us a number between 0 is less than x is less than width, less than equal to. That should be. Okay, so 0 is less than equal to x is less than width. That's the sort of range we're getting. So for our current version of width, we'll get a value between 0 and 59, which is perfect. That's the correct array index. Our indexes are 0 to 59. Okay, same for height. And we want a y. Y is equal to, and it's going to be our height, uppercase. So that's this height here I'm talking about, our constant. And that's going to give us a value between 0 and less than height. Okay. And if that location in the array is currently blank, then we can place a fish there, and we'll add one to the number of fish we've placed so far. So if that location in the array is empty, lowercase I, and our array is that one, eco array. If eco array x, y is equal to null, then we've found a place where we can put our random fish. So we'll make that eco x, y, and we'll create a fish there, new fish. So we're just creating an instance of the fish class and storing it at that location in the array. And we're also going to increment our fish count plus plus. So we're keeping track of the number of fish we've added so far. So this should add, how many fish did we say? 15 fish to start with. This will add 15 fish to a random location in our array, or in our landscape. Ecosystem. Oh dear, I'm typing in nearly the dark here. Ecosystem, right. Add fish to random locations in our ecosystem. So that's what this code here does. Okay. We probably don't want to worry about bears right now. We'll just worry about fish for starters. And one of the things we probably could do is to get all our data back out to the screen. So public string toString. So we're creating a toString method that's called automatically when we need a string representation of our predator, prey, bears and fish class. Okay, and we want two loops. We want to loop through for each vertical row. We want to get all the data for a column and display it out on the screen, or return it as a string so that the calling method can display it to a screen or a text area or wherever it wants. So let's start with the rows, which is the y coordinate. Y is equal to 0. Y is less than height. Y plus plus. And we'll do the same for x. I'll copy and paste that and change it. So int x is equal to 0. X is less than our width. X plus plus. So looping through all rows and then looping through all columns. And we want to create an output string, out string. Start off with a blank. And so we want to see what the array contains. And if the array contains a null, I'll grab that there. Okay, so if the array contains a null, we'll display a dot on the screen. A dot means empty, plus equals dot. So we're just adding a dot onto our string. We're going across the rows, don't forget. And then down across the columns and then down the rows. Else if it's a fish, else if eco array xy. And to tell us something, to tell if an array contains a fish object, you use the good old friend instance of. So if an instance of a fish, in other words, if that location in the array contains a fish or a fish object, then we want to display, let's display an F on the screen. Uppercase F. Okay, so it's going to be a dot or an F for now. We'll get that in bear later on. We'll add in bear later on. So at the end of this loop here, we want to also output a new line. Okay, so at the end of each row of data, we want to put a new line character out to our string, and then at the end of this method, we're just going to return out string. Okay, so our toString method is going to generate this table of data, rows and columns, and it's going to return that with a /n after each row. Okay. So now we need the main method, and we might also put it in here for now in our predator prey class. So public static void main. String square brackets args, just the usual main method for a Java application. And we want to create an instance of our class, which is that one. Predator prey class pp equals new predator prey. Okay, so we created an object of type predator prey bears and fish called pp, and so that calls the constructor, which places the fish in the array and initializes the array, places the fish in there, and that's all. So we want to just display that data now to the screen. So system.out.println tp.toString. Okay, and like I've showed you in prior videos, you don't need to worry about going toString there because Java automatically looks for a toString method. I'm just making it clear that's what we're calling, that's all. But you could leave that off if you like, and that does exactly the same thing. Okay, and just to make sure we are overriding the correct toString method, we'll add our good old friend override in here, which I've discussed in many other videos, so have a look at those if you're not sure what the override means. It just gets Java to do a bit more checking for you. We should be able to compile now. Compile and run. And there's our code. So you can see we've got random fishes being placed. And if you count up all the F's, there should be 15. I'm not going to worry about counting, but there should be 15 fishes there. Okay, placed at random locations in our ecosystem. We're assuming the fish can go anywhere and the bears can go anywhere. Okay. Later on, a nice little improvement to do might be to make it so only the fish can go in certain locations, and maybe the bears can only go in certain locations as well. So there's hidey holes for the fish to hide. Okay, that can be something you add later, or we add later. We'll see how we go. Now we want the fish to be able to move. Okay, so it's no good just having them stand there, or sit there, or swim there. So we want to be able to move the fish. So I'll create a new method called move. And what it's going to do is it's going to loop through all of the fish or all of the bears in our array and move them. And by a maximum one count in either direction. So either to the left or right one cell or stay the same, or up or down one cell or stay the same as well. So we're going to generate some random numbers here and work out how far things are going to move and where they're going to move to. And we're also going to make sure they're not moving outside the bounds of our array. So they can't be less than a location less than 0 or a location more than our width or height of our array. Okay, can't go outside the array. An improvement we could do in the future, if they do go out the side of the array this way, we could make it so they loop around and come in the other side, but that's something for the future. You know, okay, so okay, at random. Okay, so what we might do is, you know, often fishes and bears are happy to stay in one location, so we might have a certain chance that they want to actually move, and then if they do decide they want to move, we'll have a certain number of, you know, certain direction they move as well, up and down, left and right. Okay, so we're just sort of playing this by ear at the moment. So let's grab our loop from out of here. I'll grab that same loop and I'll get rid of everything out of there. Okay, so if the object in our array is not null, then we'll see if it wants to move. Okay, and what we could do is we could have, so we could say if the chance of moving's 50%, and they choose a random number within a certain range, then we could see if the animal wants to move and then assign random numbers to the X and Y directions it wants to move, or the horizontal and vertical directions it wants to move. Okay, so we'll get a random number called chance, double chance equals, and we're going to use our random number generator again. In this case, we're going to get random. We're going to get random doubles. So chance equals random next double. Okay, and if that chance is less than, say, 0.50, then we're going to move. The animal's decided it may want to move, and then we'll draw random numbers to work out how many cells they move horizontally or vertically. Okay, we might make this a constant as well, so we can easily change it. So let's do that, and we'll call it static final double chance to move, and we'll make it 0.50, and that means they've got a 50% chance of moving. Okay, and I like everything being nice and neat, so I'll just line all this up. Okay, chance to move. So that's our constant we're going to use there. Okay, so back in our move method, if the chance we just drew from a random number generator is less than our chance to move, then we're going to see if the animal wants to move. Okay, and we know we're dealing with an animal because the object in the array is not null. So it's either a fish or a bear or something that's not null in our array. Okay, so let's get a x change is equal to, so what we want is a value between -1 and +1. So -1, 0, +1. Whether we're moving one cell to the left, staying in the same place horizontally, or moving one cell to the right. Okay, so we'll get our random up here. So next int 2 will give us a value between 0 and 1. Okay. Next int 3 will give us a value between 0 and 2. And if we take off 1, subtract 1 from that, we'll end up with a value between -1 and +1. Okay. Or if you want to be really specific, 0, 0 or +1. That's the values we get from that. So next int 3 gives us a value between 0 and 2. And then we subtract 1 to get -1 to +1. Same for y. Y change. Same thing. And then we want to work out the new coordinate. Int x new is equal to x plus x change. And x change could be negative, so it could be +-1 or +0 or ++1. Same for y. Y new, Y change, Y, okay, and then we've got to see if that new location is valid, okay, and we're not worrying about collisions between animals yet, we're just working out whether we can move animals. So let's we'll just make ourselves a little note there, collisions. We're not going to worry about collisions for now. Just writing ourselves a note that we need to do that. So this code here won't deal with collisions just yet, but we'll come on to that later. Okay, so if x new is greater than or equal to 0 and x new is less than width, then we've got a valid location in our array and we can move the animal to that location. Okay. So we'll say x new, x is equal to that. So we're moving our existing animal, which is a fish or bear, it's just a fish at this stage. We'll move it to the new location in the landscape, which is either one cell to the left or the same location or one cell to the right. And we want to erase this location equals null. So that's okay as long as we don't have a collision. So we need to work out collisions. We'll do that a little bit later. Okay, but we're just moving animals at this stage, and we don't really want to move. Imagine if we've got the same x coordinate, so x changes 0. We don't really want to worry about doing this either. Okay, so if x change is not equal to 0 and x new is greater than or equal to 0, in other words, we've got an index of 0 or more and we still fit within our array bounds, then we can move the animal. And we're only going to do it if x change is not equal to 0. No point, there's nothing to do if it's equal to 0, there's no move horizontally. Okay. Do the same thing for vertical, just copy this code and change it. So if y change is not equal to 0 and y new is greater than or equal to 0 and y new is less than height, then our existing x coordinate, which we might have already changed here, x y new is equal to our existing fish object, and then we set our current location of our fish object to null. Okay, so we're just moving the fish across either horizontally or vertically, and if there's no change in horizontal position, we're going to move them horizontally, and if there's no change in vertical position, we're not going to move them vertically. So that should be it. Looks about like everything, I think. Still got to do collisions, like I say. When a fish hits a fish, and when a bear hits a fish, and when a bear hits a bear, and all that sort of stuff. So now what we can do, just to simulate this happening, we can do it. We can loop, say, 25 times for int k is equal to 0, k is less than 25, k plus plus. And what we want to do is loop 25 times. But we maybe also want to slow it down, so we might make it so we can hit a key to go to the next iteration, and then we can see the fish move on screen slowly, hopefully. Okay, so we need a scanner object, keyboard equals new scanner, and system.in. So we're getting input from our default system input device, which is our keyboard, wrapping that up in a scanner object, and then down here inside our loop, we're going to call next line. So keyboard next line means if they hit a return or whatever, or if they type data in and hit return, then we'll just read that in, throw it away, and go on to the next iteration. Need an import for scanner. So go back up to the top of our program, import java util.scanner. That's look pretty good. Okay. And then our loop down here just loops through 25 times. And don't forget you need to call the move method. So we'll display the grid, so display the initial grid, and then we'll do a move, pp.move. Okay, so pp is our predator and fish, predator prey object, and we're going to call this move method. Okay, so we'll display the current grid, then move, wait for the person to hit enter, display the current grid as it currently is, move the fish, and so on. One thing we could do to just make sure we're not clobbering fish as well is we could make sure that the location we're moving to is null. So we make sure that location there is null, and is equal to null. Might put that on the next line so you can see it better. Okay, so I'll just add that into the if statement. Okay, so x change is not equal to 0, the coordinates are valid, and where we're going to move to is null, so we're not going to clobber another fish or later on another bear. Okay, and I'll add that to the other one as well, down here, and it's going to be x, y, new. So the location we're moving to is null. We're not going to clobber another fish. That should be it. Let's compile and run. Okay, so there's our starting grid. And we'll hit enter. Fish, fish. And you'll see there's fish moving. There's fish moving about on screen. Some are going vertically, some are going horizontally. There's some going left and right. They're only going slow, of course, because we're hitting enter to move the fish around. Okay, but they're moving around, which is quite nice. We didn't have any crashes or anything, so our arrays aren't going out of bounds. So everything's working great. All our if statements are working, which is great. What we could do to improve that, so we don't have to keep hitting enter and making it all jerky, we could have a timer set up so that it just calls move and display, or toString every half a second or something if you wanted to. We can make a timer. Let's do that. Public void move and display. So currently we're just displaying to the console screen. Okay, I'm going to call move. Okay, and we won't do that anymore down here. We'll comment out our loop down here, and what we'll do is we'll call this from a timer. Okay, so we'll bring in a timer, import java x.swing.timer, and now we can create a timer object and use that to run the move and display method every half a second or whatever we want. Okay, so let's do that. Timer t equals new timer, and we're going to run that event, which is going to be our move and display. pp.move and display, and we also got to tell it the interval we want. Okay, so let's put our milliseconds in. So this is how often the timer runs. So we've got a 500 millisecond delay, so every half a second this code here will run, which is this code. Now this is an instance method, so we don't have pp. pp is an object down here in our main, so we don't have access to this. So all we do is print line this, in other words display the current object, which is going to call our toString method, and we just call move, not pp move. Okay, so it's just about print line this, means call our toString method. We need a string representation of our object, so call the toString, and we're going to call the move method, which is our move up here that we just looked at earlier, that move. So toString and move. Okay, so that calls toString and that calls move. Okay, so we've got our timer there, and then we need a t.start, and then to stop our program exiting, because we're running this to console mode, we need to just have a new line key here to hold our program open until we exit, until we want to exit. Okay, so keyboard.next line there down at the end. In other words, it's just stopping our program from closing so that the timer doesn't start, then our program ends straight away. It's being held up. Okay. Control 1, that should be it. Control 2, and there's our code, and you can see all the little fishes there moving around. It's a bit jerky. That's okay, it's only a console screen output. Yeah, the fish is all moving around, up and down, left and right. Pretty good. Pretty easy, pretty good. That's a nice start. Okay, so let's just review our code. So we've got our imports to bring in some libraries we need from Java. We've got an animal class, which is just an empty class. We've got a fish class, which extends animal, and a bear class, which extends animal. And the reason we did that is for our inheritance. We used inheritance so that we can have just one array that holds everything. So an animal could be null, it could be a bear, it could be a fish. Later on we could add further animals, and we're still doing things in a nice object-oriented way. If we later on we want to record attributes for each animal, for example lifespans and breeding rates and mortality rates and all that sort of stuff, we can add all these into these classes here. Okay, so double mortality rate equals 0.10 means that there's a 10% chance that a fish dies at any point in time. I don't know, however it works. Okay, so we can always improve these things later. They're just empty classes for now because we don't need any data, okay, in them. And then we've got the width and the height of our landscape. It's just a 2D flat plane. The width and the length, or whatever you want to call it. I've called it height. Maybe length is a better name. I'm thinking of width and height because I'm drawing it on screen, so I've got, but probably width and length would be better names. The number of fish we want to start with, and the chance that those fish have got to move is about a 50% chance. And if it's a 50% chance that they're going to move, and we get a random number in the right location, then we'll see how far left and right they want to move, and vertically as well. There's our storage array for all our landscape cells, and it's got 60 by 20. That's our grid size. Our random number generator called random. Our constructor, or default constructor. We're creating the array. We're setting the fish count to 0. And while fish count's less than the number of starting fish we want, 15 fish in this case, we'll get a random coordinate. If that random place is empty in the array, then we'll put a fish there. So echo array xy equals new fish. We're just putting a fish into that location in the array and adding one to our fish count. Okay, that's all that constructor does. Then we've got a toString method. That's getting a string representation of our data. And we're looping through our landscape array or our echo array. And if it's a null location, we're putting out a dot to the screen. Otherwise, if it's a fish, we're putting out an F. Just so we know what the data is, we can see it on screen. And at the end of every row of data, we're putting out a new line because we're displaying it on the console screen. So this just returns a string which we can then print line or put in a text area or whatever we want. Okay. Displaying a label, displaying a dialogue if we wanted to, we could do anything with it. We've got a move method here, and it loops through each cell in the array, and if it's not null, we work out whether that cell wants to move or not with our chance to move here. So we get a random double, and if it's less than our chance to move, then we see if the animal wants to move. We're going to change X and a change Y, and it's either one cell to the left or one cell to the right, or staying the same, or one cell vertically or one cell forward, one cell backwards, all stay the same. Okay, so I've gone with width and height because I'm drawing things on a screen and that's how I'm thinking, but really we have a flat landscape where it's a length and a width maybe might be better, but it doesn't really matter. Then we work out our new x coordinate and our new y coordinate. X new equals x plus the x change, and y equals y plus the y change. And if the x change is not equal to 0, in other words we are moving, and the new x coordinate's valid, it's inside the bounds of the array, and there's nothing there to collide with, the object at that location is null, then we can move the x coordinate position. And then we do the same for y. We move whatever's there to the new location and set the original location to null. Move whatever's there to the new location and set the original location to null. So I can move the x and the y independently. So if we're up against the left-hand boundary and we can't move left anymore, we can still move up and down. Okay. Even if we are trying to move left, we can stop the left moving, but we can still move up and down. So that's why I'm doing these separately, considering the x and the y separately. So we've got to do the collisions. That's still got to be done. We've got a little move and display method here, which prints out the current state of our array and then calls move. And then down here in our main method, we're creating a predator-prey object called PP. We're setting up a timer to kick off every 500 milliseconds or half a second. And we're calling the event, which is our move and display method, which is this chap here. So it's going to print out the array to the screen, and then call the move method every time it's called. And then we start off the timer, and then we stop our program from exiting by calling the next line there. So that's just going to hold our program up from exiting. So the timer will keep running. And that's it. Okay, so that's part one. In part two, we need to add bears in, we need to add collisions in, we need to add breeding in so that if two bears collide, neither move, they create a new bear, and same for fish. And we also need to create bears eating fish. So fish can't eat bears, but bears can eat fish. So that's what we'll add in the next video, all those sorts of fine-tuning things. Okay. Hope that was useful for part one. Thanks for watching. Look forward to seeing you in part two.